Good morning, Geo Metro Ninjas. In this lesson, we're going to be talking about independent and dependent events. Okay, so basically, independent and dependent events are just compound events, meaning that they're a combination of two or more simple events. When we talk about independent, the outcome of one does not affect the outcome of the other. We are going to find this by multiplying the first event by the probability of the second event. So for our first example, we've got a coin that is tossed and a spinner that is spun. Find the probability that of tossing heads and spinning a consonant. So if you look at your spinner on the right down here, okay, this guy over here on the right, A, B, and C. So 2 out of 3 of those are consonants. I think so. English teachers, help me out. Okay, so we're going our simple probability of rolling a heads. Okay, simple probability of doing that, it's 1 out of 2. There's 2 possible outcomes. The outcome we want is 1/2, so that's the probability of heads. Okay, and we're going to multiply that by the probability that we spin a consonant. So there's 2 consonants on that spinner to the right. Okay, so that's a probability of a con. With fractions, we multiply straight across, or you could cross cancel if possible. So we're just going to multiply straight across for this one, though. 1 times 2 is 2. 2 times 3 is 6. And that reduces to 1/3. A number cube is rolled, and the spinner on the right is spun. Find the probability of tossing an odd number and spinning a vowel. Okay, so we're going to now, again, we got 2 simple events. So probability of an odd number on a dice is 3 out of 6. Oops. So that's probability of odd. Okay, and then times, there's 1 out of 3 vowels now. So that's a probability, I don't know why I keep doing that. Probability of a vowel. Okay, remember we multiply straight across. 3 times 1 over 6 times 3. If you can recognize cross cancel, go for it. Cross cancel, guys. Say 3 times 1 is 3. 6 times 3 is 18. And then, of course, we always want to reduce our fractions when possible. So we get probability of 1/6. Now, for a dependent event, okay? Dependent. One event is going to affect the second. Okay, and we're going to find the probability of the first event times the probability of the second after it has taken place. Okay, so when we look at this example 3 here, we've got 2 red, 5 green, and 8 yellow marbles in a jar. Okay, we're selecting 2 marbles at random without replacing the first. Okay, without replacement is going to be your big key, flashing lights, all that stuff, that this is a dependent event. Okay, what is the probability of 2 green marbles being selected? So note, since the first marble is not replaced, the first event affects the outcome of the second, creating a dependent event. So first off, we need to find the total number of marbles. We got 2 red, 5 green, and 8 yellow. So we've got 2 plus 5, 7 plus 8 is 15. So there's 15 total marbles. Okay, so we've got the first probability. So the probability of green. Okay, and then times the probability of green again. So when we first reach into our jar, there's 15 marbles total. Right? And out of those 15 marbles, 5 of them are green. So this is our first pull. So we first go into the jar, 5 out of 15, there's 15 total marbles, 5 of those marbles are green. We are going to assume that we did exactly what we wanted. We're going to assume we pulled a green marble. And now we're going to take that green marble out and set it off to the side. Now, we've removed a marble, so there's only 14 left. And of those 14 marbles, because we're going to assume we pulled a green marble, there's only 4 green ones left. Okay, so this is our second pull. So we pulled that green, we put it off to the side, we go back into the jar to see another one. So we're going to multiply straight across. So 5 times 4, 15 times 14. So we get 20 out of 210. And you guys can math frac that, and you get 2 out of 21. Okay, that is dependent. The outcome of the first affects the outcome of the second. Okay, let's do a couple more examples, and then I'll set you all free. Okay. A cooler contains 4 Cokes, 5 Dr. Peppers, 3 Diet Dr. Peppers, and 2 root beers. Real quick, what's the difference between Mr. Pibb and Dr. Pepper? About 8 years of schooling. I know. Y'all couldn't go a day without a Coach O joke. Okay, sodas are selected at random. Without replacement, there's the flashing yellow lights. Those we need to be ready for. What is the probability that we get a Coke followed by a Dr. Pepper? So first off, we're going to total up the sodas. Got 4 Cokes. Can't write in highlighter, dummy. 5 Dr. Pepper. 3 Diet Dr. Pepper. 2 root beers. 4 plus 5 is 9. Plus 3 is 12. Plus 2, 14 total. So we want probability of Coke. And then without replacement, somebody's getting that nice refreshing Coca-Cola. We want probability of Diet Dr. Pepper. Okay, so when I first reach into the cooler, there's 14 total sodas, and of those 14 sodas, 4 of them are Coca-Colas. We're going to assume we pulled a Coca-Cola. So now there's only 13 sodas left in the cooler. And of those 13 sodas, 3 are Diet Dr. Pepper. Okay, so now that we got that, we multiply straight across. You can reduce early, you can cross cancel, whatever you want to do. We're just going to multiply straight across. 12 out of 182. Math frac in your calculator. 6 out of 91 is the probability that we pull a Coke and not putting that Coke back, reaching back in and getting a Diet Dr. Pepper. Hey, this last one, it kind of puts both of them together. So we're just going to do them. We're going to do the setup and the math. So bag contains 6 green, 8 white, and 2 blue counters. So we've got 16 total counters. So each time we're going to do one with replacement and one without replacement. So with replacement, we want a green and then a blue. So there's 16 markers the first pull, 16 markers the second pull. Remember, we're not putting anything, we're putting it back after we pull it. So there's 16 greens, put it back in the bag, and there's 2 blues. Multiply straight across, math frac, 3 out of 64. If we're not replacing it, so we reach in, there's 6 out of 16 greens. So we pull that out, set it off to the side. Now there's only 15 counters left in the bag. And of those 15, there's 2 that are blue. Multiply straight across, math frac, we get 1 out of 20. Okay. So the probability is better without replacement. Okay. White and white. So again, we're reaching in, 8 out of 16 are white. Putting it back into the bag, 8 out of 16 are white. Okay. Math frac reduces to 1/4. Now without replacement, the first time we reach, 8 out of 16 are white. We are going to assume we pulled white. So now there's only 7 out of 15. Okay, each one goes down because we're assuming what we wanted to happen happened. So in our total now, Math Frac, 7 out of 30. Blue and then not white. So when we reach into the bag, so 2 out of 16 are blue. If there's 8 white, that means 8 are also not white. Okay, we put that blue back. Okay, multiply straight across, Math Frac gives us 1 out of 16. Okay, now here's a little trick. So 2 out of 16, I reach in the first time, it's blue. Okay, again, we know that one of the counters is going to go down, but because we assume we pulled a blue, that is reducing the amount that is not white. So it's 7 over 15. That's a little extra trickeration in there. Multiply straight across, Math Frac. Just put it right in your calculator, guys. Just in parentheses 2 over 16 times, in parentheses 7 divided by 15. Shoot, I think you can just type 2 divided by 16 times 7 divided by 15, and it'll still give you the right answer. Okay, white and not green. Well, we know there's 8 whites. We're putting them back into the bag, and then there's 6 green total, so that leaves 10 not green ones. Multiply straight across, and we get 5 out of 16. Okay, in our last example, so we reach in, pull out what we want. It was a white. Now when we reach back in, there's only 15 counters because we pulled a white one, and since it is not a green, there's only 9 counters left. Again, we're going to assume what we wanted to happen is what happened. Multiply straight across, Math Frac, and it gives us 3 out of 10. Guys, this completes our independent and dependent. Once you get a 100, you can always go back and keep practicing. Practice, practice, practice. The more you guys practice these, the better it'll be.